Hi everyone, so we're going to do the next topic now. We're going to move on to solving equations that are a little bit more complex. We just did the basic linear equations, so we're going to try some ones with brackets and pronumerals on both sides. And we actually did these last year, but you may not remember, so we'll go a bit further with it again, and hopefully this will remind you. So when we are solving problems like this, the order for how we do things can be really important. Now, the thing to remember here as well is each equation could need to be solved in a different order. And you need to look at each one individually and decide which order you're going to do it in. So here are some things that may help you. So equations with brackets can be solved, but we first need to expand the brackets. So here's an example for you. So 3x plus 1 equals 2 becomes 3x plus 3 equals 2. You need to expand the brackets first and apply that distributive law we worked on last term to get rid of any brackets that we've got. If we've got an equation where it has pronumerals on both sides, you want to collect like terms. So you're going to move any like terms onto the same side and simplify as much as you can. So an example of that might be 3x plus 4 equals 2x minus 3. You need to get the x's together. So you would move the 2x over to the 3x by subtracting it from both sides. And you could have brackets and pronumerals on both sides. That's pretty normal in an algebraic equation as well, and you're going to have to do a few steps. So obviously the more in there, the more complex it becomes, but let's have a look at some of them together. So these are the ones I wanted to look at. So let's look at A first. So A is 3x minus 4, so that means 3x minus 4 all has to be multiplied by 2 equals 11. So the first thing I'm going to do is distribute that 2 to everything in the bracket, so multiply it. So 2 times 3x equals 6x, 2 times minus 4 equals minus 8, and that equals 11. Now it's simply a matter of collecting like terms and getting to a final answer. So I'm going to move that minus 8 onto the other side, so that is going to become a positive or a plus on the other side. 6x equals 11 plus 8. 6x obviously equals 19, and we don't want 6x, we want x. So we're going to divide both sides by 6. So you could leave your answer as an improper fraction like we have there, or you could simplify it down to a mixed number. Just keep in mind what the question is asking and make sure you do whatever that is. Of course, you could go to a decimal too if that is appropriate, but you always want the most accurate answer. And remember, sometimes decimals aren't that. If you have to round, stick with a fraction unless it says answer as a decimal. Okay, let's do B. 2x plus 3 minus 4x equals 8. So again here, we need to get rid of those brackets first. I know we've got 4x on the same side as the other x term, but we need to distribute that 2 across the bracket, and then we can do as we did before. So 2 times x is 2x, 2 times 3 is 6, minus 4x equals 8. Now it's pretty easy to see that we can simplify like terms. So 2x minus 4x is going to give us minus 2x. Remember that the sign sticks with the term. Plus 6 is still there, equals 8. Now you could move the 6 across at the same time, but at this point I recommend that you don't, because you need a bit more practice before you do that, and it's really easy to make mistakes if you do that. So now I want to move the 6 across to the same side as the 8, collect that like term, and we're going to take 6 away from both sides to do that. 8 minus 6 minus 2x equals 2. Now remember, we want x, we don't want minus x, so we have to divide both sides by minus 2 to get there. 2 divided by minus 2, so x equals minus 1. Because we've only got a negative in either the top or the bottom, our answer is going to be negative, so that just moves out the front. Okay, C. 5x minus 2 equals 3x minus 4. Now, nothing to distribute here, but we do need to collect like terms. So I'm going to move the x's together first. And I'm going to move the 3x over to the same side as the 5x. I'm going to take it away. And the reason I've chosen to do it that way is because I'm going to end up with a positive x number. Now, it doesn't matter if you end up with a negative x number. I guess the preference is just that when you're working with a positive number, it's actually a little bit easier. So I'm going to leave this side in exactly the same order as what I started with and just move the minus 3x over to there. Simplify, so that's going to become 2x minus 2 equals negative 4. Now I need to collect my numbers. So I need to add 2 to both sides to get rid of it on this side. So minus 4 plus 2, 2x equals minus 2. And again, I'm going to divide here by 2. I don't want x, so x equals minus 2 over 2, or x equals negative 1. So it happens to be the same. So you notice in B, the negative was in the bottom of the fraction and I ended up with a negative number. And in C, the negative was in the top of the fraction and I still ended up with a negative number. It doesn't matter which one it's part of. If there's only one, the answer is going to be negative. Okay, let's do our final example. So in this case, we've got brackets on both sides of the equation. So that is no problem, but it does mean we need to distribute both of those brackets before we do anything else. So you can easily do that at the same time because they're on different sides. So 3 times 2x equals 6x, 3 times 4 equals 12, and that equals 8 times x, which is 8x, and 8 times 1, which is 8. And once you've got it here, simplify where you can. Now, let's have a go at moving the numbers and the x's at the same time. So I want to move, in this case, my 6x over to my 8x simply because I'm going to end up with a positive number, which means if I'm going to do that, I need to move the 8 over to the 12. So 6x I'm going to move over with 8x, and 8 I'm going to move with 12. So what I will have if I do that in one step, and as you get better and better, you probably do want to do it this way, I need to minus 8 from both sides, and I need to minus 6x from both sides. So that is going to leave us with 4 equals 2x. Of course, my x should be on my left-hand side. My unknown should always be that way. And I want to divide both sides by 2 because I've got 2x and I just want x. So in this case, x equals 2. So you can see in this case, I've missed out a few of those steps you've been used to doing. There is no need for you to do that at this point, but as you get better and more confident is something you want to consider doing. And as you head into grade 10, it's probably what is expected. But by all means, do all steps at this point, particularly if you are prone to making a few little errors. Okay, so that's all I'm going to do. The questions you're going to work on in class are exercise 2E, these that were set. We're going to go right up to some problem solving questions. And your homework for the next lesson is watch Solving Word Problems screencast and take notes for that one, which is the next OneNote page. Okay, any questions? See me in class. See you then.